This topic is called higher order derivatives. And we've sort of discussed this before. So when we were talking about physics applications, you might remember that we started off with a position function, or the displacement function. Okay, I cannot write today. That we called s of t. And if you took the derivative of s of t, what did you get? So if you took the derivative of the position function or the displacement function, what did we get? What was the derivative of the position? The rate of change of position, what do we call that? Do we remember? I know it's been a while. Or did we talk? It was not acceleration, but when there's one before that, velocity. Yeah, there we go. Now, if you took the derivative of velocity, what did you get? Acceleration. I don't think I'm spelling acceleration right, but whatever. Okay, so you started off with your position function, and you took the derivative of position, and you got velocity. And then we took the derivative of position again by taking the derivative of velocity. That is called the second derivative. So we started off with position, we took its derivative, we got velocity. We took the derivative again and we got acceleration. Okay, so there's a way to talk about taking multiple derivatives at a time. You have your function, and then you could take the derivative and you put 1 prime. You can take the derivative again and you can put 2 primes. After a while, it's really tedious to keep putting more tick marks. So if you want the third derivative, you would put 3 in parentheses so that you know you're not raising it to a power. So if you want the fourth derivative of position, you would write s. It looks like a power, but it has in parentheses. Is that sort of making sense? You can keep taking the derivative over and over. Okay, so that's one way you could write it. You could write a prime for the single derivative, 2 tick marks for second derivative. After that, we stop writing tick marks and we put the number in parentheses. Now you might remember that there were multiple ways of writing the derivative. Instead of writing s prime, we can write ds dt. That means you're taking the derivative of s with respect to t. Now how would you take the derivative twice? You write d2s over dt squared. d2 means derivative twice. Take the derivative twice of s. How would you write the third derivative? d3s dt cubed. That means start with your function s, take the derivative 3 times. d4s over dt to the 4th means start with your function s, take the derivative 4 times. Okay, so we call these higher order derivatives. Sort of making sense so far? We'll do it. Yeah. There are. One of them's called impulse, and another. Yeah, and the other one's called jerk. I don't think there's anything after that fourth derivative, to be honest, in physics. No. So you start off with your position, and then you look at how your position changes. That's velocity. That's speed. And then you can ask yourself, how is your speed changing? The rate of change of speed is acceleration. And then you can ask yourself, well, how's your acceleration changing? That's impulse. And then you can ask how your impulse is changing. That's jerk. So you start off with looking at where the object is in space. That's position. And then you're wondering how the object is changing its position in space. That's speed. And then you can wonder about how the speed is changing. That's acceleration. And then you can wonder about how the acceleration is changing. That's the impulse. So it's like a little weird to think about it. Like acceleration, when you accelerate, how do you change, when you're in a car, how do you change your acceleration? Like what would, exactly. So how quickly you are moving the gas pedal is your impulse. Where your gas pedal is determines your acceleration, and that changes your speed. You know how if you push down the gas pedal, your speed will start changing, right? If you just push down the gas pedal, the car starts going faster and faster, right? So where the gas pedal is determines your acceleration. If you move the gas pedal, that changes your acceleration. That's impulse. Cool. So hopefully that gives you like a model to think about this. Okay, so let's do an example. We are going to find the second derivative for f of x equals 2x squared minus 3x plus 1. Okay, so because we want the second derivative, so we would write this as we want the second derivative of our function. Okay, one of the ways you can write this is, if you think about it, d squared is 2d's, right? So the way you would write this is, I get the second derivative by taking the derivative of my first derivative. Okay, so this d dx means take the derivative of whatever is inside the brackets. Now, what is inside the brackets? My first derivative. So I'm going to need to first calculate my first derivative, and then I'll have to take the derivative of that. So how do you find that first derivative? Well, we find that first derivative by calculating the limit. We're going to take the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. Okay, so let's calculate these off on the side. F of x plus delta x is 2 times x plus delta x squared minus 3 times x plus delta x plus 1. So you're going to get 2 times x squared plus 2x delta x plus delta x squared minus 3x minus 3 delta x plus 1. Okay, so 2x squared. Okay, so let's multiply it through. We're going to get 2x squared plus 4x delta x plus 2 delta x squared minus 3x minus 3 delta x plus 1. Okay, so the top, or the numerator of this limit is f of x plus delta x minus f of x. So we're going to have to take that and we're going to subtract 2x squared minus 3x is going to be plus 3x, and then minus 1 will be minus 1. So if you look at those two, some things are going to cancel. The plus 1 and the minus 1 is going to cancel. The 3x and the minus 3x are going to cancel. The 2x squared and the minus 2x are going to cancel, which leaves me with a numerator of 4x delta x plus 2 delta x squared minus 3 delta x. And all of that is over delta x. So I simplified the numerator. It was f of x plus delta x minus f of x. That's what I calculated right down here. We had f of x plus delta x minus, and then f of x on the bottom, and I canceled the terms. I put the result up there in the numerator. Okay, now looking at that numerator, what can we do with it? So if you look at that numerator, there's something you can do. I'm sorry, am I... Yes, yeah, you can factor out a delta x. So you get delta x times 4x plus 2 delta x minus 3. And now the whole point of doing this was because you had a delta x on bottom, which will now cancel. Right, so now you have your function which agrees except at a point. So now you could do the limit as delta x approaches 0 of 4x plus 2 delta x minus 3. And now you can just do direct substitution. You get 4x plus 2 times, the delta x goes to 0, so you just plug in 0 there. And what are you left with? 4x minus 3. This is your first derivative. So your first derivative is 4x minus 3. Now, we aren't done. We did not want the first derivative. What is it that we actually want? We want the second derivative, which you get by taking the derivative of the first derivative. So we're going to take the derivative of 4x minus 3. How do you take the derivative of 4x minus 3? Well, you have to calculate a limit again. We're going to do the limit as delta x goes to 0 of f of x plus delta x, which is going to be 4 times x plus delta x minus 3. That's your f of x plus delta x, but the function you're dealing with is the 4x minus 3, the derivative. And then you're going to subtract f of x, which is just 4x minus 3. And it'll all be over delta x. So this one right here is your f of x plus delta x. This one here is your f of x. My new f in this case is my derivative because I'm taking the derivative of that. Okay, so we need to do some simplification. Let's simplify the numerator right over here. You're going to get 4x plus 4 delta x minus 3 minus 4x plus 3. The minus 3 and the positive 3 will cancel. The 4x and the minus 4x will cancel, leaving me just with 4 plus delta x. So I get the limit as delta x goes to 0. That whole top becomes 4 delta x. It's all over delta x. The delta x's cancel, leaving me with just the limit as delta x goes to 0 of 4. And what is the limit of a constant? No, that's the derivative of a constant. What's the limit of a constant? The limit of 4 is 4. Oh, it's cool. Yeah, no problem. So this is your second derivative. Your second derivative of that function is the number 4. Okay, so you started off with f of x equals, what was it? 2x squared minus 3x plus 1. We then calculated the first derivative, and we got 4x minus 3. And then we calculated the second derivative. Notice I'm writing it in the different notation this time. And we got the number 4. Okay, this is like a lot of work, right? Because we had to do that limit calculation twice. So that sort of sucked.